Good morning, students. Today we are going to discuss about electrophilic substitution reactions of benzene. For example, halogenation of benzene, sulfonation of benzene, nitration of benzene, and Friedel-Crafts alkylation and Friedel-Crafts acylation of the benzene with mechanism. First of all, I want to say that electrophilic substitution reactions are the characteristic property of aromatic compounds, and in our syllabus benzene and its derivatives are the aromatic compounds. So today we are going to discuss about electrophilic substitution reactions of benzene with methyl. For example, halogenation. For example, halogenation, nitration, sulfonation, and Friedel-Crafts alkylation and acylation. Halogenation of benzene or chlorination of benzene. When benzene is treated with chlorine in the presence of dry AlCl3, then we get chlorobenzene as the main product. Chlorobenzene as the main product. When benzene is treated with when benzene is treated with chlorine in the presence of dry AlCl3, then we get chlorobenzene as the main product. This reaction is known as chlorination or halogenation of the benzene with chlorobenzene. Okay. Now we are going to discuss about mechanism of this reaction. Mechanism of this reaction includes three stages. Mechanism of this reaction includes three stages. Step first, generation of electrophile. Step first, generation of electrophile. In case of chlorination, electrophile is chloronium. And Cl plus chloronium ion is the electrophile. So here is chlorine, Cl2. Here is dry AlCl2. Dry AlCl3 in this reaction acts as a Lewis acid, or it acts as the catalyst. Dry AlCl3 is a Lewis acid and it acts as catalyst in this reaction. So, two electrons of bond shifted towards the chlorine atom and we get Cl plus and AlCl4 minus. Now this is our electrophile, chloronium ion. Now step second, attack of electrophile. In case of chlorination, attack of chloronium ion on benzene. Now step second, attack of of electrophile Cl plus and formation of sigma complex. This is all. Now you can see the benzene like this. 6-member ring with 3 pi bonds. 6-member ring with 3 pi bonds. Now you know in benzene resonance take place. These pi bonds are localized. Continuously rotate in the benzene ring. So I can say now here is chlorine Cl plus. This pi bond shift towards this. Then negative charge acquires, this carbon acquires negative charge and this carbon acquires positive charge. Plus attracts towards negative charge. So it attacks on this carbon and we get this type of structure and we get this type of structure. Here is hydrogen, you know. Here is chlorine. This is the aluminium ion or sigma complex, I can say. This is sigma complex or aluminium ion. Now I want to explain you about the resonance in aluminium ion, resonance in sigma complex. Okay. So resonance in sigma complex. Resonance in sigma complex. So I can explain here about the resonance in sigma complex. Sigma complex. This is our one benzene. Here is hydrogen. Here is chlorine. Here is double bond and here is double bond. This double bond shifted here. This double bond shifted here. So this carbon acquires negative charge and this carbon acquires positive charge. So I can write in positive and negative forms a double bond and this positive charge localized here. Here is hydrogen and here is chlorine. Now here is another double bond. The electrons of this double bond shifted towards this carbon. Now this carbon acquires negative charge and this carbon acquires positive charge. And here double bond shifted here. So positive charge will be here. Now I can write the resonance hybrid of these three structures. You can see the positive charge localized from this carbon to this carbon. So I can write the resonance hybrid of sigma complex. You can see the positive charge localized from here to here, localized from here to here. So this is the resonance hybrid of sigma complex. Or I can say sigma complex, aluminum ion and resonance hybrid. Now step third, removal of H plus and formation of substituted product. Now step third. Step third. Removal of H plus. Removal of H plus. Removal of H plus. In sigma complex from left, I can write this structure like this. Now, the positive charge is here, and here is a double bond, and here is a double bond. Here is hydrogen, or here is chlorine. Now, AlCl4 negative works here. AlCl4 negative works here to form. Now, this hydrogen remove as a proton, it donates both of electrons to this carbon. Now, negative charge acquires this carbon and double bond form in between this and this carbon. We get chlorobenzene or substituted product as the product, and now this H plus reacts with Cl minus to form HCl, and this AlCl4 becomes AlCl3. So I can say AlCl3 here acts as catalyst. This is the chlorination of benzene with manganese.